Good morning. In this lecture series, we see about the variation formulations and Ritz methods. So last class, we discussing about the weight residue method and also different types of weight residue methods we have to carry out. It is another one type of method is called as a Ritz method. It's mainly called as a variational formulations. Okay, so it's a powerful of the computational approach that the transformation of the complex differential equation to elegant the algebraic problem through the variation the principles. So what is the Ritz method? So the Ritz is a method is a sophisticated the variation techniques that appropriate solutions to boundary the value of problem by converting the differential equation into the minimizing the problem of energy functional. The name after the stress physics Welter risks. This method has been become the cornerstone is the computational mathematics with the widest spread application across the engineering, mechanics, structural analysis, and quantum mechanics and numerical physics. The problem transformations and what is called as this convert the differential equation into the energy minimizations. And the approximate solutions is providing the system approximation with the controllable accuracy. And the practical applications are the essential of for the structural quantum and the thermal analysis problem. So, what is the core idea from the variational problem on the approximation solutions? The Ritz following the systematic the force processing that is the elegant transformation continuous problem into the discrete algebraic systems. The first one is the formulate the function. So, begin the formulation functions whose the extreme the corresponding to the solution of the differential equation. Choose the basic function. Select the appropriate safe functions that is to satisfy the boundary conditions and form the complete basics and constructing approximations that express the approximation solutions as using the linear combination of the basic functions and minimize the unsolved. Determine the coefficient by minimizing and reducing the problem to the solving the algebraic equations. So what is the simple variation problem is the example. So let's consider the problem statement of the consider the functional is nothing but I of y is equal to integration of 0 to 1 y square plus y dash the whole square into dx. So what is the boundary condition here? I am consider as a y of 0 equal to y of 1 is equal to 1. That means when you put as a x is equal to 0, the y value is 1 and the x is equal to 1 and y is also 1. So what is the solution for the appropriate approaching of this type of equation is select the polynomial basics like h11, h2x and h2x square. The formation of the bar element is like a1 plus a2 2x and a3x square. So applying the boundary condition to the constraint the coefficient as a result, resolving the result algebraic systems yields the coefficient value that when producing the appropriate solution is remarkable close to the exact analytic solutions. So the Ritz and Gallatin method is a closely relative. Both are the methods belongs to the family of the weight residual method, sharing the fundamentals variation principle through they are different in their requirements and generalized. So for the variational formations is nothing but both the methods are employ variational principle and expand the solutions using the basic function approximations and minimizing the error in a different way, converging properties of the many cases of both producing the tangential algebraic systems and leading the combined the Ritz-Galerkin approach. So during the boundary conditions, the rich methods is require the basic functions to satisfy the essential boundary conditions. The Galerkin method is a more flexible and general. So during the finite element analysis, both are the theoretical foundation of the FEA and enabling the sophisticated structural, mechanical, and the physical simulations. So why is the using of the Ritz method? The Ritz method has to become the insensible in the modern of the computational method mathematics and engineering, offering the unique advantages that make it the method of choosing for the complex problem. So the problem simplifications are the transformation irreducible and the differential problem into the a manageable algebraic system that can be solving using the standard numerical techniques and the computational foundations that serves as the theoretical basics for the modern computational method, including the finite element analysis in the engineering and physics. The controllable accuracy, the providing the system approximation with the adjustable precision by the increasing the number of basic functions are needed. The versatiles, the applications, enabling the solving problem with the arbitrary boundary conditions and the complex geometry and non-uniform material property effectively. So let's summary of this class. The variation calculus and the Ritz method is a variational formulations and the Ritz method. While the variation formation, the governing equation conversions and the energy or function approach. So during the energy approach, we have to further classify the equivalent minimization problem and the stationary functions. For Ritz method, the approximation techniques, methodology and application. During the methodology, the admissible trial function, unknown coefficient determination, and function minimization. Thank you.